Okay, let's see our first classification example. Like earlier, we say we using this data set is we call the CKD CSV file. We read the whole table. We only show the first 3 patient information. But you can see here we will have about a little under 160 patient information. So they have their age and also all the exam result from this patient. So this file we have so many patient health information, but most important thing we want to do the prediction is about at the end the last column about the class. So this file is doing the research about the chronic kidney disease. So if the patient have this disease, the class will be 1. If not, will be 0. So that's why you can see if we just according to see the class data, we try to group that. So we have less than 1/3 the patient has the disease. So the purpose what we want to do is we just see, of course, you can get all the information about the patient. But if we try to do some research just according to the specific disease, can we try to find some meaningful data attribute? So then they have the relationship. So that will help us to, instead we just do all the exam from a patient to identify the disease, or we can just have maybe 2 or 3 attribute on those exam data. So then we can save some money to see if predict the patient have that disease or not. So that's why here the first one, right? When we try to see the relationship, the first one we can do is we try to do the visualization. So that's why here we make the first scatter plot. We just using the white blood cell count and the glucose data. Okay, so then we just have the scatter plot. So then you can see here the patient without the chronic kidney disease, that will be in the dark blue. And if the patient has that disease, that will be 1. Okay, so then we just try to see in this scatter plot, because remember we try to classify our data. So then we want to see from this relationship, can we identify just according to the patient white blood cell count, all the glucose, we can know they have the chronic kidney disease or not. For example, just say one patient, the glucose index is about 300. So then the white blood cell count is maybe 10,000. Okay, so then we just see here. So then we can see we don't have exactly data, but one thing we can see in this region, all the cross data will be class equal to 1. So we can see in this data, yeah, this patient has very good chance they have the chronic kidney disease. Then how about if we say the one patient they have the glucose is 100, then the white blood cell count is 5,000. So then from here you can see, yeah, we do have one data. That's class 1. But then close to this region, actually the most of data they don't have that disease. So that's why you can see if we try to do the classification according to these 2 numerical attributes, we try to predict our outcome. Since in this region, even we know almost all the patient without this disease, they are in this region. But they do have some patient with the chronic kidney disease. They are here. So that's why from the scatter plot, since we see the overlap, they don't have very good separation. So these 2 attributes may be not a good combination. Okay, so of course we can get advice from the doctor. So then we can check some meaningful attribute to make the scatter plot. So that's why we choose the next two attribute is we still using the glucose, but then we using the other one, we use the hemoglobin. Okay, so then we see the scatter plot. So then you can see here, actually this one have much better separation between the class 1 and class 0. You can see here for the patient without the chronic kidney disease, they are in this region. Okay, so that's why we can see if they have higher glucose from here, if they are more than maybe 150, okay, so they are all the possibility to have that chronic kidney disease. And if your hemoglobin is under maybe 12.6.8, they have that disease. Okay, so this one actually is much better separation between the two categories. So that's why from here, can we try to make our model? Yeah, we can, right? Because one thing is we can find out actually if your glucose have the maximum value. Okay, if you over this maximum value, you have very good chance you have the chronic kidney disease. Okay, or you can see here if you are under certain hemoglobin index, so then you will have very good chance you are the class 1. Okay, so that's why according to that, we make the two value here. The one is the maximum glucose for the class 0 and the minimum hemoglobin for the class 0. Okay, so then we're using our Python maxima and the minima function. We're just using the column. We only get the class 0. Okay, so for all the class 0, we try to find the glucose, then we find the maximum value. Then the same thing for the class 0, we find the hemoglobin, we find the minima. So since we have these two data, right, so that's why we feel like if we want to classify, you are either class 1 or class 0, passing this hemoglobin and glucose data, then we can return you are either class 1 or class 0. So you can see here, since we return the class 1, right, so that's why you see here. So you are either have lower hemoglobin data or you have higher glucose number. So then you are class 1. Okay, so that's why here, let's see, if we have a patient, okay, so then hemoglobin is 15, then the blood sugar is 100. From this scatter plot, we can know, right, they are class 0. Okay, yeah, so our result is. So, or the other patient, yeah, our hemoglobin is 10. Okay, then the blood sugar is 300. Okay, so then, yeah, you see that's a class 1. Oh, sorry, this one. Yeah, this is the class 1. Okay, yeah, so that's our first example about how we're using the classification. Okay, so you can see here we have two input. We're using two numeric attribute. Okay, because we're using from our sample data, then we find out they do have the nature to separate the region for the class 0 and class 1. So then we use that to predict according to the patient hemoglobin data and the glucose index. So then we can tell you are class 1 or class 0. Okay, so you check, do you have any question, and make sure you discuss with your classmate, your peer. So I hope you work with your peer and watch the video together. Okay, so if you don't have any question for this data set, this example, I want you to think about, in this example, is the data-driven model or not? Okay, yeah, of course, anytime pause the video before you give the answer. Yeah, actually this one, since we're using the true numeric data, yeah, we do have our sample data set. Okay, so that we can say that's the data-driven model. Okay, but one thing is we also need to be aware how this model we will apply to. Because one thing is, like we say, it's not the population. We have, this is the, the patient information. We have almost 160 patients. But those patients maybe came from only one hospital or one specific region. Okay, so that's why, yeah, we do show you the prediction kind of makes sense. But on the other hand, also we need to be careful when we train our model. Okay, but this model we train, actually we're using to predict, possibly maybe can just apply for our region. So we are not sure if out of this region or this hospital, in other hospital or other states or something, we will still have the same predict result. So that we need to be careful about when we train our model. Okay. Yeah, so that's our first example. Yeah, you can see here, right? So actually when we have our data, yeah, so our classification, oh yeah, earlier I forgot to say, you can see here, actually our data can be we have numerical attribute. We also have some categorical attribute. So that's why here our example, when we do the scatter plot, of course we're using the numerical data. Okay. So then let's see another example. This one actually just a banknote. So the banknote, you can see the class, we just say that's our output. Okay. So then actually here actually we even don't understand what those they are all only have numeric data. Okay, but we don't understand actually the column mean. Okay, but one thing is, again, we see how our class distribution. So they are about half and half, class 0 and class 1. Okay, so the same thing, even we don't understand what those columns mean. Okay, so the first time still we just choose the true attribute. This one we choose the first and the third column. Okay, so then we put the scatter plot. Okay, yeah, so you can see, like earlier we say, right, since they are not have very clear region, they overlap. So using for the classification, it doesn't really see that's a good model we should use. So then we decide, then how about we try, so since we try the first column, the third column, so then we try the second column and the last column to see. So then, yeah, again, still, they kind of have some overlap. Okay, so then we will see how should we do. Okay, so one thing is this one, we want to show you this example is when we try to using, they are all numeric data. So then we make the scatter plot on the two-dimensional array, a two-dimensional graph. But sometimes, since they overlap their data, but maybe because they are in the two-dimension view, okay? So sometimes they still have the overlap in two dimension. But here we want to show you, even they have the overlap in two dimension. Is that possible because we only use the two dimension? If we add a higher dimension, then here we have instead only use two, because we have two attributes, so we use two dimension. So then how about this time we try to use is we make our dimension a little higher. So that's true. These two scatter plot, we only use two attribute, their relationship. So then maybe if we add one more, instead using the two attribute, so how about we make the three attribute together? So since we have three different attribute, right? So that's why they will become a three-dimensional graph. Okay, so then we see here. So actually you can see here they still overlap a little bit. But then still once we change, become the three-dimensional. Okay, so actually their separation of the data kind of is much better than the previous two. right? So even right, they still have overlap, okay, but it's much better. Okay, so that's why here, this example, we just want to show you. So earlier, two-dimensional is kind of very easy. We can make the scatter plot that we use for the past 2 week. Okay, so the first thing when we're using the classification, we just show you, maybe we can make the scatter plot with 2 attributes. But if with 2 attributes, they still doesn't have a good separation. So maybe we can bring them to a higher dimension. But when you have a higher dimension, on the other hand, that means also you involve more column. Okay, so then we make the scatter plot. So this scatter plot, actually the result give us a better view. So then using this model, so then we may have a better model to have our prediction. Okay, so that's our 2 examples about our classification.